The universe is stranger than we imagined. And with every new discovery, it grows stranger still. For centuries, we saw the cosmos through the lens of our own solar system, a familiar, orderly place. We assumed other star systems would follow the same blueprint. But across the unfathomable dark, we're finding worlds that don't just break the rules, they rewrite them entirely. Some planets wander utterly alone. These are the rogues, cast out from their stellar nurseries to drift between the stars. With no sunrise and no orbit, their existence is an endless, silent night. Their only warmth is a fading memory of their violent birth, a slow geothermal ember in an endless, starless sea. Could life cling to such a world, huddled around volcanic vents in a lightless ocean? The thought is as chilling as it is profound. Others are lighter than they should be. The superpuffs. These are worlds so bloated and airy that a gentle cosmic wind could almost carry them away. In systems like Kepler-51, gravity barely manages to hold a cotton candy sky together. Their atmospheres are vast but incredibly thin, like planetary ghosts. They are fluffy, fragile, and utterly improbable, challenging our models of how planets form and hold themselves together. While some worlds have no sun, others have two. Circumbinary planets trace complex, looping paths around a pair of stars. Imagine a world with two shadows, where sunsets are a daily spectacle of twin stars dipping below the horizon, painting the sky in shifting colors. Their orbits are a delicate gravitational dance, a testament to stability in the face of cosmic chaos. Then come the lava worlds, born of fire and fury. Orbiting perilously close to their stars, their daysides are eternal forges where rocks vaporize into a thin, searing atmosphere. Planets such as 55 Cancri E or K2 141b could host entire oceans of molten magma, with mineral vapor blowing into supersonic storms, then raining stone and silicate back down onto a churning, glowing surface. Some of these hellish worlds may hide treasures beyond imagination. Carbon planets, formed in systems rich with the element, could have interiors where immense pressure has crystallized carbon into planet-sized diamonds. Beneath a crust of graphite and a sky thick with smog lies a core that is a single, colossal gem. A diamond in the rough of the cosmos. But not all seas are made of fire. Some worlds may be completely drenched, water-rich subneptunes or Hesian worlds wrapped in deep globe-spanning oceans and high-pressure ices. Here, sunlight filters into an endless blue, and continents may never rise. These worlds pose a tantalizing question. Could life exist in such a place, thriving in a liquid realm far larger than any on Earth? Life, or at least existence, can orbit death. Around pulsars, the collapsed, spinning ashes of exploded stars, planets circle in precise, haunted rhythms. PSR B1257 Plus and 12 hosts worlds forged from the debris of a supernova, shaped by catastrophe. They remain steady under a relentless lighthouse of radiation, bathed in energies that would sterilize a world like ours in an instant. Many planets are tidally locked, their faces fixed permanently toward their suns. On the day side, a scorching, unending glare. On the night side, an eternal, absolute frost. But between these two extremes lies a thin, temperate band of twilight, the Terminator line. Here, a possible refuge exists, where powerful winds might mix heat and cold into something potentially survivable. A world of perpetual sunset. Gas giants can be stranger still, with weather systems that defy belief. On ultra-hot Jupiters like WASP-76b, temperatures are so extreme that iron vaporizes at dusk and condenses as metallic rain at dawn. A storm of liquid metal drifting through a roaring sky. On other worlds, conditions are right for clouds of corundum to form, raining down rubies and sapphires. And on one exoplanet, HD 189733b, it rains glass, sideways, in winds blowing over 7 times the speed of sound. And in compact systems like TRAPPIST-1, 7 Earth-sized planets are packed so tightly that they tug on one another in a perfect orbital resonance. They form a celestial clockwork, a delicate gravitational chain where the orbit of one planet dictates the rhythm of the next. It's a beautiful mathematical hint of what else might be possible in the architecture of solar systems. Every time we look, the catalog of the unusual grows. Rogue and puffy, molten and oceanic, dead star circling, Terminator calm, metal-raining giants, and diamond-hearted worlds. A bestiary of planets we never predicted, each one a new chapter in the cosmic story. The evidence for these worlds is often faint, a whisper carried across light years. We see the subtle dip in a star's light as a planet transits, the gentle wobble of a star tugged by an unseen companion, or the precise timing of radio pulses from a distant pulsar. These are the clues, and patterns only emerge when we listen long enough. With each new survey and every patient pass, signal stacks upon signal. Faint hints sharpen into the silhouettes of alien weather, the pull of alien gravity, and the glow of alien heat. We are moving from detection to characterization. We are learning to read the chemistry of atmospheres by starlight, decoding the elements sipped from a sunbeam as it passes through a thin ring of air around a world crossing its star. That sliver of light tells us of water, methane, or even vaporized rock. The first maps we draw are messy, incomplete sketches, but they hint at incredible depth, at complex chemistry, at dynamic weather, and at worlds so profoundly unlike our own that they force us to reconsider what a planet can even be. With every discovery, we unlearn the simple picture we once held. There is no single blueprint for a solar system, no one way for a planet to be. Variety, it seems, is the fundamental rule of the cosmos, and what remains unknown could fill oceans. Which atmospheres can endure the fury of their stars? Which ones break apart and rain down strange, exotic weather? Where, in all this beautiful madness, might the temperate edges of habitability truly lie? The path forward is clear, though the journey is long. More eyes on the sky, wider spectra to analyze, and a deep, abiding patience. All in the service of turning these faint, ghostly hints into solid structure. Take a slow breath in. Somewhere, out there in the dark, iron may be falling like rain. A silent heartbeat of lightning marks a night that will never, ever end. And a long, slow breath out. Somewhere else, a global ocean may sleep beneath the perpetual twilight of a locked world, calm, silent, and waiting. We have only just begun to listen. The cosmos is speaking to us in the language of planets, and its incredible story is only just starting to unfold.